Good morning everyone, I'm Benjamin Whitcombe from the University of Hull. I have a background in oceanography and marine science, and I'm currently doing a PhD there looking at how offshore wind infrastructure is influencing our frontal systems and plankton and algae growth in the central North Sea. But today I'll be talking you through some oceanography in our East Mee region. So, what actually is oceanography? It's the study of physical, chemical and biological changes and features in our oceans. The way we do oceanography is to analyse the ocean's history, its current condition, and then use this data to be able to predict any changes that we may have in the future. In the middle here's some work I did in the Arctic down to the Mediterranean on a sailing ship, the European Space Agency. This is my colleagues here taking some oceanographic data on wind speed, wave height, temperature and other boat sensors as part of a science watch. On the right here is what we call a CTD. This is a large instrument that we send down throughout the water column, which enables us to measure temperature, salinity, and the depth that all this happens, and other variables like chlorophyll fluorescence throughout the water. And this was on a trip with the RRS Discovery looking at the offshore wind farms around Hornsea 1 and 2, and then also at Kincardine in Scotland. But why should we actually monitor changes in our ocean? Well, the continual research efforts actually enable us to monitor current affairs and project future change, as this can also allow us to identify anomalies which can aid in targeting areas of conservation or further needs, also as well as targeting areas where fisheries may change. It also allows us to see socially where changes might happen for tourism, i.e. if waters are warming and we can predict future warming, we might see more bathing or activities off of our coastlines. It can also be a drive for fisheries and energy, such as offshore wind, putting in our North Seas and areas specifically spatially what we pick, as well as also monitoring for defence and weather pattern analysis. Monitoring these also allow us to pick areas of species change and habitat management. Recently there's been a lot of news focus on new species that we're seeing in the waters, as well as an increase in species such as grey seals, whales and tuna. There's also a headline that's been maybe fish is going to change to squid and chips. Or we've seen a lot in the south coast of the octopus coming more to that region, so maybe our seafood will change. So what actually is the East Mee region? Our coastal area is running from Flamborough Head down to the Thames of London. Flamborough Head is one of the most diverse benthic areas in the North Sea, as well as supporting fisheries and bird species. Our offshore region, however, covers a much larger extent, running up to Dogger Bank, miles offshore of Newcastle, all the way down into the English Channel. But how does oceanography actually shape this? In our waters, water is moving with the currents and tides. Along our coastline, the currents move from the Atlantic waters in the north, so much colder water flows down past the Scottish coastline into our waters. Some of this makes its way into the English Channel and moves tidally. This water also is transported off to Denmark and up to the Netherlands. The channel waters from the south also move northerly through our region, and also over to Denmark and the Netherlands, which tends to be much warmer throughout the year. And with our waters throughout the year, stratification can occur. This is where solar radiation within spring and summertime increases, and this causes the surface of our waters to be warmer than the deeper waters. And in the southern areas, we get more turbulence in the water, which causes the water to be mixed. So the temperature at the surface and depth tends to be more homogeneous, same at the top and bottom. And then, so we have two different areas along our coast where the environment is extremely different, which could drive different species to live in these regions. So what actually was the temperature annually in 2025? We can see here that the English Channel waters on average, even with this stratification, the surface waters tend to be warmer than our waters that are in the north, coming from that cool Atlantic water. And 2025 as itself, when we compare to our long-term average from 1993 to 2026, it is all warmer than that long-term average. Specifically in our offshore stratified regions, that this surface heating has happened a lot more. But the big takeaway I'd say is the whole area is warming and it's getting warmer. When we can look at a specific month, September, however, we see that there is a lot more heating off of our southern regions and coastlines. However, looking at an anomaly for September 2025, it was actually cooler off of our southern coastlines than it has been over the long-term average. And these stratified areas were a lot warmer, again, up to half a degree warmer than they have been over the long-term period. Looking at the dowsing wave net from the CFAS data hub, we can see we had a continuous warm period from March to October, ranging up to 2 degrees warmer than the long-term average in September time. This was also a large period of little water influx and rainfall, causing droughts in the northern areas off of Yorkshire. Then this is also a driver for turbidity. We can see that there are large areas of turbidity around our coastline with a flux into the central North Sea, as well as in the top right is the Dogger Bank area, which is an area of shallow sandbank waters, so it tends to be more turbid. However, looking possibly due to the drought period we had in 2025, the Humber estuary and waters off of the Thames were actually less turbid than the long-term average, and those that were offshore, however, seem to be quite similar to long-term average or slightly higher. I think Rodney will pick up a bit more on this later. So some of the work we've done off of Scarborough, I know it's a bit more north of the region, but last summer we've done one of our monthly research trips to look at chlorophyll and temperature throughout the water column, but I think this shows quite well how water is different off of coast and offshore. At Station 1 we are 20 miles offshore, and the water is quite blue and clear. We had a record Secchi depth disc, which is an oceanographic instrument to see water clarity. This was down to 18 meters. At Station 2, this was quite rich in chlorophyll in algae production, which is why the waters are more green, and that's just doing a zooplankton net. And then at Station 3, it's more red-brown, which is due to sediment influx off of coast and that mixed water. Around here, our Secchi depth was around 7 meters, so there's a big range in waters only 20 miles offshore and coastally from visibility. So I'm going to talk a bit about our wind, waves and storms throughout 2025. Overall, wind speed tends to be greater at sea than it does on land, which is why we've got offshore wind farms out there. Coastally though, waters over 2025 seem to be calmer in wind speeds than they have been in the past 20 years. And the overall wind speed anomaly tends to be overall negative for that year. When we look at wave height change from our wave buoys, we see a gradual decrease in wave height throughout the years, and these becoming calmer coastally over time. We, however, do not have many offshore platforms to measure the wave height, so I think a push might be there for them. Taking the same specific point throughout 2025, we can see a few named storms in January, August, October, and 2 during November. With this, there are many peaks, such as in February and September, that were unnamed storms. To name a storm, it has to be as severe or moderate impact to people on land. So I think I'll push to name storms where impact could be on fishers or offshore infrastructure, since that's increasing throughout the years, maybe a future outlook. So our biggest storm for the UK in over a decade was Storm Ewan in January 2025. This, however, had a limited effect on the East Mee region and mainly hit off of Scotland and the Irish coast. And 2025, over a long-term period, average was actually one of our calmest Januaries since 1995. What wasn't calm though was Storm Floris in August, one of the biggest first name storms of the year, hitting wind speeds up to 20 miles per hour plus, constantly off coast, with a high anomaly offshore in Dogger Bank and off of the Flamborough region. Coastally, however, this wind speed was not as great. We also had Storm Amy and Benjamin in October, 2 storms in 1 month. Wind speed again was highly focused offshore, having little effect up to the coastal regions compared to long-term scale. Storm Claudia in November also hit with great devastation to offshore areas and a little more increase to our coastal regions, particularly around the Humber and the Wash. So overall, 2025 was a warmer year than average, with prolonged periods of both drought and high temperatures from March to October. This region was also more turbid in 2025 than the long-term average. However, coastal turbidity seems to be decreased, possibly due to less influx from rainfall. There were numerous named storms throughout the year, bringing high speeds and wave heights, and these mainly occurred in autumn. However, the overall wind speed and wave height present a calmer year than average. Looking at named storms and how they affect our seas and our coastal areas may bring about a different way of naming these, as there are numerous times when wind speeds were high and wave height was very high. However, there was no naming or focus on these storms. There's also a need for more in situ offshore monitoring, as our main focus with moorings is coastally.